So again, I'm moving into the second part of the semester for my Physics A-B students. So we're just going to continue reviewing like we were before in the videos. So the next unit, or the first unit for the second half of the semester, is Unit 8, which is electrostatics. The subtopics include a charge, Coulomb, and electric fields. Here are some electrostatics charge. So remember, there are conductors and insulators. So conductors allow electrons to move freely. Metals tend to be good conductors. You also have insulators, which don't allow electrons to move freely, and some examples are plastic, rubber, wood, and glass. Methods of charging: conduction, induction, friction, and grounding. So if you need a good review of these methods of charging, you can find this at the website below, or to the right, or you can get more interactive experience by clicking the link here. Reviewing Coulomb's law. Opposite charges attract, like charges repel. So we can calculate the size of the force charges put on each other using the Coulomb's law, which is the formula that you see on the screen. Get some practice solving these types of problems by clicking here, or if you need some help solving these types of problems specifically, check out this YouTube tutorial by clicking the link below. The next module, which is electric current and circuits. Some subtopics include current, circuits, conceptual and problem solving, complex circuits, and electric power. I know I did a extra help session with a live lesson over the different types of circuits, so if you need some review, that's something else that you can watch over these concepts. So specifically electric currents and circuits, and then current. So electric current is the rate of flow of electric charge. Current will flow where there is a potential difference between the 2 points. So several factors affect the resistance of a material. You should know them. What devices use electrical energy, and what safety devices are out there to protect our appliances, homes from the current. You did a virtual lab on this. AC versus DC, what do they stand for and what's the difference? And then make sure you review Ohm's law. What is it? What are the symbols and what do they stand for? What are the units for each component of Ohm's law? Continuing, here are some questions that you need to be able to answer, and you can find some practice circuit tests by the link below. But let's look at the questions. Number 1 says series versus parallel versus complex, which remember is a mix of both series and parallel circuits. What is potential difference or voltage in various spots? What is the current of various spots? What is the equivalent resistance, which is you use equations for these. What is the total resistance, and when is the term used? What stays constant throughout the circuit, and what happens to the circuit if bulb blank is removed, and advantages and disadvantages of different circuits. So if you don't feel confident being able to answer those questions, that's when you need to take the practice circuits test by clicking that link below. Moving on to the next module, magnetism and electromagnetism. Here are some subtopics. Magnetism, induction, right-hand rule, or the RHR, generators, motors, and transformers. Here are some magnetism facts that you need to make sure you understand. The first natural magnet was made of magnetite. Within atoms, the spin of the electrons produces magnetic properties. Ferromagnets are metallic elements whose atoms have many unpaired electrons. What happens when a magnet is heated, broken in half? This was definitely on a quiz during that unit. Diamagnetic is a form of magnet that is considered to be non-magnetic. The needle on a compass points to geographical north, which is magnetic south. And then the magnetic field area around the magnet indicates the magnetic force is present. Moving electrical charges or current will induce a magnetic field. Similarly, the presence of a magnetic field will cause charges to move. So the right-hand rule, or the RHR, is used to determine the direction of force, current, and or magnetic field while knowing 2 of the 3. So if you need to see the right-hand rule explained, make sure to check out the video on the right, especially if you don't know what that is. Moving on to the next unit, which is waves. So the topics include wave basics, reflections, and then also interference. So here are some wave basics. Make sure you are able to calculate. Remember that you can use the formula sheet for the final exam, but frequency and period, wave speed, frequency, and wavelength. You should also be able to label amplitude, wavelength, crest, trough, compression, and refraction. And you need to make sure you know the following. What is the medium and what does it affect? Longitudinal versus transverse waves, including examples. I know I did another help session on this. And then for some practice with wave properties, there is a practice quiz below that you can check out. Waves and wave interactions. Reflection, which is the turning back of a wave at a boundary of a new medium. When a pulse hits a rigid boundary, it has been reflected and inverted. Waves sometimes interfere with each other, which is constructive and destructive. Same thing, kind of piggybacking off of waves, and specifically sound waves. So some topics include sound wave basics and then sound wave applications. So here is a huge list of different YouTube tutorials to watch. I strongly encourage you to make sure you know the different between sound transmission, speed of sound, sound intensity, pitch/loudness, Doppler effect, resonance, harmonics, sonic boom, and beats. So again, I suggest in the slide that you order these from most familiar to least familiar, then spend your time on the last 3 items to best prepare for the exam. So you probably don't want to watch all of these, but maybe like the ones that you got wrong on your module test or even the quizzes. Categorize those questions in one of these topics and then make sure to watch the one that you missed the most amount of questions in. The next module is electromagnetic waves. Here are some subtopics, which is electromagnetic radiation, wave particle duality, and color. Make sure you know the order of waves on the electromagnetic spectrum. So know when the wavelengths increases or decreases. Know when frequency increases or decreases. Know when the energy increases or decreases. Know common facts of each type of wave. So radio includes TV waves. A microwave causes food molecules to vibrate sympathetically. Infrared is heat sensitivity. Visible, which is sensitive to human eye. UV can cause sunburn. X-rays, which is second highest frequency. And then you also have gamma rays, which is used in cancer radiation therapy. So again, there's the radio type wavelength below. That kind of helps with the different concepts between the different frequency and wavelengths. You also need to know basic facts about electromagnetic waves and how they compare to mechanical waves. So this is an important concept, and a lot of students got these two confused. So here are some vocabulary words, and when I read this, if you don't know all the words in blue, you definitely need to go back and review the module, especially looking at the ones that you don't know. So the photoelectric effect proved that light was a particle. The quantum theory states that EMR, which are the electromagnetic radiation, is made up of photons. Light interactions, which is the reflection, refraction, diffraction, and interference. Make sure you know light terms, which is illuminated versus luminous. Laser stands for light amplification throughout the stimulated emissions of radiation. Incoherent light versus coherent light. So again, make sure you review these topics if one of them is unfamiliar with you by reviewing the module or emailing me for extra help. Unit 14, which is optics. Subtopics include plane mirrors, concave mirrors, convex mirrors, light refraction, converging lenses, and diverging lenses. So you should be comfortable with these diagrams and what the letters stand for. You should be able to identify when images are reduced or enlarged, real, virtual, and upright, inverted. To help study, make yourself a Miro's cheat sheet. Summarize everything under each diagram. You can click here to see an overview of optics and get some ideas of what to include on your cheat sheet. I also did another help session on specifically mirrors when it came to convex versus converged lenses, and talked about those real versus virtual images when it comes to mirrors. Moving on to optics, which are lenses. So we have converging lenses review video. We have a converging lenses practice questions link. We have a diverging lenses review video and a diverging lenses practice questions link. So again, if you are unfamiliar with this topic or need some extra help or practice, check out those links provided on this page. Instead of memorizing image results from mirrors and lenses, understand how the ray diagrams work and how to draw one each time you get a question. Have scratch paper handy while taking the final exam. Unit 15, which is nuclear physics or modern physics. Here are some subtopics: fusion and fission, radioactivity, relativity, and nuclear reactions. During both fission and fusion, matter converts to energy. You know the whole E equals mc squared thing. It's probably important. Critical mass, which is the minimal mass of fissionable material necessary for an uncontrolled chain reaction. Fusion happens naturally on the sun. Fusion is good because it has no radioactive waste, but bad because it requires very high temperatures. Einstein was famous for his relativity experiments. He considered how Newton's laws apply in different reference frames. Michelson and Morley also contributed. You should know what experiment they did. Einstein referred to the time as fourth dimension. The unified theory says three forces are actually one. Know what these three forces are. Dilation clock experiment. Know what of clock that was used, and how do special and general theories of relativity affect GPS. If you need to review this in 7 minutes, you can click in that link to the right. It's a great video. Also, you should know alpha, beta, and gamma reactions, atomic number, mass number, define nucleon, isotope, make sure you know what that is, fundamental forces, natural transmutation versus artificial transmutation. So if you need a quick lesson on radioactivity or any of the stuff that I listed on the left, you can watch and listen to a tutorial video here. Again, thanks for joining in the review session. Please email me any questions you might have after watching this review. Thank you guys for having a great semester, and I want to wish you as well a Merry Christmas and Happy Holidays.